Hi everybody, now we're going to review chapter 9. Okay, here's our first question. The visible light we see from the sun comes from which part? So it comes from the photosphere, and the photosphere is the surface of the sun. Okay, next question. The sun is a stable star because what makes the sun a stable star? Okay, so the reason is that the sun is in balance between two forces. At the center, you have nuclear explosions that are pushing the sun outward, or trying to explode the star outwards. But at the same time, gravity from the sun's mass is collapsing the star inwards. And when those two forces balance, that means that the sun either grows or shrinks. So it's a stable star. Okay, next question. The number of sunspots in solar activity in general peaks over what time period? So it's over every 11 years. And you can see it here. About every 11 years, you get these peaks. Okay, here's the next one. What is the average size of a granule on the surface of the sun? So it's the size of Texas. All right. What are the two ways that energy is transported away from the core of the sun? So the first way is just above the core. It's by radiation in the inner regions of the sun. And near the surface of the sun in the outer regions, it's by convection. So you can see it again here in the inner region is by radiation. And near the surface of the sun, it's by convection. Okay, so we'll skip this one. Okay, here's the next one. What process creates energy? What process creates the sun's energy, and where does it occur? So those pictures are hints. So the process that creates energy is nuclear fusion of hydrogen into helium, and it occurs in the sun's core. So you can see here, hydrogen nuclei, or just protons, get fused to create helium nuclei. Next one, name the layers of the sun in order of distance from the center of the sun. All right, so from the center of the sun outwards, you have the core, then it's the radiation zone, and then it's the convection zone, and you reach the surface, which is the photosphere, and above that you have the chromosphere, and lastly you have the corona. So you can see them again here, from center all the way out to the edge. Okay, and here's the next one. So through what part of the sun do solar winds escape? So solar wind escapes through holes in the sun's corona. So you can see these holes here in the sun's corona. Next one, why are sunspots darker than their surroundings? So what makes sunspots darker is that the sunspots have strong magnetic fields. And what the strong magnetic, so these are the magnetic fields. And what the magnetic fields do is that they slow down the motion of the gases. So you can see this gas is trapped here. It's not going anywhere. And effectively what that does is that it stops the motion of the gas, and that effectively cools the gas down. And because the gas becomes cooler, it becomes darker. Next one, what is the difference between a prominence and a flare? So a prominence is a loop of trapped gas above the surface of the sun, whereas a flare is an explosion of material. So you can see materials being ejected here. So it's an explosion of material ejected off of the sun. Okay, next one. At what temperature does nuclear fusion of hydrogen occur? So hydrogen fusion occurs at 10 million kelvins. All right, and next one. How are sunspots related to solar activity? So the more sunspots you see, the more active the sun is, and the more explosions there are. Okay, this completes the review for Chapter 9.